In the podcast before, the one previous to this, you saw how to calculate the standard cell potential. You break everything up into, bring it over here, the half reactions, and you're going to do cathode minus anode. Now that's not any different than what we've done before, because everything we do, looking at change in temperature or change in anything, it's final minus initial, right? Okay, so let's think about the flow of electrons. Where do the electrons end up? They end up in the cathode. And where do they come from? Who produces those electrons? The anode. So that's still your final minus initial. So cathode minus anode, again, which is just final minus initial. Now when you do this, here's that chart. Oops, 824, I think it was. Nope, not here either. Here it is, 827. So here is the chart right here. I also put something really similar in the PowerPoint, and these are all of your half cell, and here are your electron volts here. So remember that whenever you do this, anytime you have the anode, you have to switch it, which you saw in the previous one there. Okay, so you switch the sign all the time for the anode. Okay, and you just look up your specific half reaction that you have. So you look at your half reaction, let's say it's nickel, and then you see, oh, that's negative 0.23. And then here's that chart I was saying, here's the standard potentials. Okay, so let's see how to do these. So it says, determine the half reactions, balance them, do the full balancing, and then get the numbers from the chart, and remember to always flip the anode. So let's go ahead and let's do one of these. Oops, wrong thing. Here we go. Okay, let me see where the arrow goes on this reaction. PowerPoint between hydrogen and aluminum. Okay. Okay, right here is my arrow. Okay, so here are my products, here are my reactants. Okay, so first let's split these into half reactions here. Okay, so let's put my aluminum over here, my aluminum and aluminum. Do you see that my aluminums don't have any oxygens or anything? They're just aluminums. So that's just one half reaction there. So aluminum solid plus, or goes to aluminum 3 plus. Okay, can you see here, because I have hydrogens and oxygens and and waters, where do those go to? Well, look what has oxygen in it, and that's where all the hydrogens and oxygens will go to. Do you see I have an NO3 minus, or let me change the color. I have an NO3 minus here, I have an NO. Those go together, you can see, but it will also include the hydrogens and the oxygens. How do I know that? Because it started off with oxygen. Remember, when we balance them, you have oxygen, you had to balance that with water, and then you balance the water with hydrogen. Anyway, so that's how I know the waters and the hydrogens go with the nitrogens with the oxygens. So let's see here. I have NO3 minus plus 4H plus yields to NO plus 2H2O. Okay, now let's balance these. Let's do aluminum first, okay? Aluminum, one aluminum. Okay, where would we put the numbers here, the electrons? Let's see here. The aluminum would have aluminum to aluminum 3 plus. So this side needs to become more negative, so I'll have my 3 electrons here. Okay, now let's do the one over here. Okay, I have 3 oxygens, 4 hydrogens, 1 nitrogen. So when you have this all here, it should be mass balanced. So let's just look at the charge where the electrons go. Okay, So I have NO3 plus 4H, and what I'm looking at is oxygen, because we're nitrogen. I mean, oxygen always will have a oxidation state of -2, and hydrogen will always have one of +1. So we're looking at nitrogen. So nitrogen over here. Okay, so I have a nitrogen and 1 oxygen plus 1 oxygen with an oxidation state of -2, and overall this is 0. Okay, so that means the oxidation state of nitrogen here is, +2. Okay, so here it's a +2. Now let's look at this one here. Let me change my color. Do it over here. I have 1 nitrogen, and I don't know the charge of it, plus 3 oxygens, and those have a -2 oxidation state. And what is the overall charge? You see here it's -1, because that negative there, so it's -1. So nitrogen -6, 3 times 2 is 6, equals a -1, okay? So nitrogen equals to +5. Okay, so here nitrogen is +5. So it went from 5 to 2. The difference there is 3. Now which side do I add the electrons on? Always the more positive side, so it's +3 electrons. So those are my half reactions right there, okay? Now I need to find those. Oh, and let's put that, go ahead and put that in as a cell reaction, standard cell. So what it would be, it'd be aluminum, okay, solid, okay, separated, so it's like your arrow there, by a aluminum 3 plus, I don't need to put the electrons there. Why do I know to write this one first? I'm about to write it into cell notation. Why? Because this is the anode. How do I know it's the anode? Because it produced electrons. You see the electrons are in the product. So here, anode will always produce electrons. Okay? Now, that's everything there. Now I separate, now you see that's my anode. Now this whole reaction here is my cathode. Okay, so now I'm going to my other reaction and I separate that by 2 bars. This is like my salt bridge. Now I put all of my reactants here. That'll be NO3 minus, it's a comma, 4H plus, separate, here because this is my reactant, here's my product, would be NO, comma, 2H2O. Okay, so this is in the cell notation here. Now let's look up our reactions here. So my anode is whenever I have aluminum going to aluminum 3 plus. Okay, now let's look at what that cell potential is. Let's see, come over here. Aluminum to aluminum 3 plus. Let's see if I can find it. I'm also very blind. Here it is. Aluminum to aluminum 3 plus, right here, is negative 1.66. Now remember, for the anode, we always have to flip the sign because it always gives you in the form of the cathode. Okay? So this potential here, so we're going to say standard shell potential, she here, is going to be, in this case, we're going to say positive 1.66, right? Volts. Okay? And what we're going to do here, now let's look at this one. So NO3 and a 4H plus. So we're going to look at that reaction. Here we go. NO3 here it is. See, NO3, 4H plus, 3 electrons is a 0.96. Oops, not that. So this one over here, this reaction is 0.96 volts. Now what you do here is you just add them. Now there's 2 ways to look at this, and I'll show you here in a minute. So I'm just going to add them. 1.66 to 0.966, or 0.96. So 1.66 plus 0.96, that gives me 2.62 volts. And that's how much electricity, how many volts you're going to get from this reaction here. Now I want to show you this too. Now you see how I went ahead and changed the sign here? When you change the sign, your formula just becomes, anode plus the current here of the cathode. Okay, the volts of both, adding them together. Okay, now if you use the formula I just showed you where you have, final minus initial, so you would have your cathode minus your anode. This is the same formula, but just written differently. You see I have the negative there? That means, so in this one you change your sign. This is how you use this one. Okay, if you change your sign. But you see here, that's built into it. That changes your sign for you so you don't have to change it. So I'll show you. So if I would have put, like in the table it says negative 1.66. Okay, so if I plug this in here and change the color, I would have had my cathode, which is 0.96 minus, and then what is the voltage? Negative 1.66. You see here, a negative and a negative become a positive, so I still get 2.62 volts. Alright, let's do another one here. Here. Okay, so if this is the full equation here, okay, let's write the half equations and put them in the cell notation. Okay, right here, see my aluminum and aluminum will go together, so I'll have aluminum solid will go to aluminum 3 plus. So let's go ahead and put our electrons here. So this went from a 0 to a 3 plus. So which side do electrons go? On this side. Why? Because they always go to the more positive side. So let's see here. I have electrons that were produced, so that makes this the anode. Okay, so if I start writing the half reaction, or the cell notation here, that would be aluminum solid, separated by a line, because that's my arrow, goes to aluminum 3 plus. Okay, now I need to separate it by 2 lines, because now I need to look at my cathode. So I have copper 2 plus, because I'm looking at copper going to copper, goes to copper solid. So I have a 2 plus, and over here this is 0. Okay, so where do my electrons go? Over here. You see that? Okay. Now let's look here. 2 electrons here. So if I start writing this in, copper 2 plus, arrow, copper solid. Okay, so now all we need is look this up. Now I do want to point out here, you don't need to worry about balancing the charge in this. If it asks you for the full balanced equation, so the balanced equation, that's when you're going to balance the charges and everything. You don't need to do that here, okay? Right here, we're just looking at the actual half reaction. So you separate them out. You don't have to worry about balancing the charges or anything. So here it is. Now let's look at the cell potentials, okay? I had the aluminum. Which one was it? Which aluminum? Already for aluminum solid to aluminum 3 plus. Okay, so aluminum here says the negative 1.66 again. Right down negative 1.66. And the copper 2 plus to copper. Look closely because this is copper 2 plus to copper plus. We don't want that. We want to copper solid. Look. It's somewhere on here. Here it is. Copper 2 plus to copper solid is 0.34. So if we plug it into anode or cathode, cathode minus anode, we would get cathode is 0.34, anode, and that's a point, it's not a negative, is negative 1.66. Notice I'm not changing the sign because I'm putting it in this formula here. So 0.34 minus the minus 1.66. Oops, it did not like that. We're going to get 2. Anytime these come out positive, that means it's producing electricity, and that means it's spontaneous. Okay, so I hope this helps you to figure out how to calculate the standard cell potential.